In physics, the only thing we like more than a graph of results is a straight line graph of results. It's not just the neatness, the y-intercept and the gradient can tell us things like initial speed, acceleration, the spring constant, the density. In this lesson video, I'm going to go through the graphical technique on how to find the density of a metal wire using a graph. Now, density is defined by the equation mass over volume, but we want a straight line graph. In maths, you should have learned that the equation of a straight line is y equals mx plus c. We're going to start by just considering a straight line through the origin, so that becomes y equals mx. So instead of d equals m over v, we want it to look more like y equals mx. So I'm going to rearrange the equation. So rearrange that and you can get m equals dv, mass equals density times volume. Now if I plot a graph with m on the y-axis, v on the x-axis, then d is the gradient. So what we do is design an experiment to get 7 values of m and 7 values of v, and then we plot the graph. Draw a line of best fit and calculate the gradient using rise over run. And that's it. The gradient is equal to the density. Now notice how the gradient has units. Rise has units of kilograms and run has units of meters cubed. So the gradient has units of kilogram per meter cubed. Just like density. Now you might be wondering, why do we bother with this? We could just do the experiment once, calculate the density, done. But we've already understood a little bit about the idea of doing repeats, and the gradient of a graph is a really good way of averaging out the results. So we get 7 sets of data, we plot the graph, we draw a line of best fit, and our line of best fit gives us a nice average. It takes time, but it gives us better results. And if we want to be a top scientist, that's what matters really.